Okay, good morning class. So today we're looking at Euclidean geometry. Euclidean geometry, open this here. Okay, at this point we spoke about tangents. We mentioned that if you got a radius and a tangent, the radius will say 90 degrees to tangent, and your reason is radius perpendicular to tangent, and the converse was also true then. And then we went on and we went to prove the tan chord theorem. Okay, as I said, that this proof here, although it has an asterisk there, it wasn't tested, okay, and I don't think it needs to be tested. However, the link to this theorem can be found in the description box below. Okay, so from now till before you write your grade 12 final exam, view it at least once. It's fairly simple. Just the construction and prove the congruency in the two triangles. Okay, and then with that we'll prove that AT is equal to TB. Okay, and the reason for that is tangents from common point to external point. Okay, we'll do some application of that now. And then theorem 9a, that's the theorem we just proved now, which is the tan chord theorem. And we said the converse is also true. If you can prove that angle MNP was equal to angle R, or angle RNQ is equal to angle P, then MNQ will be a tangent to the circle through PRN. Why? Because it's angle between line and chord equals angle in alternate segment. If you find it difficult to remember this, no problem. All you write is the converse, or the converse to tan chord theorem. That's all you write. Converse, tan chord. That will also get you the full mark for your reason. You guys okay with that? Okay. I made it a note to remember, so you'll always see me writing angle between line and chord equals angle in alternate segment. Okay. And that was the theorem. Here we are as you're speaking about common tangents. There's common tangents. These circles touch internally at A. There's a common tangent, which means to say it's common in both circles. It's externally at A. Can you see it? And then here we got a common tangent. This circle does not cut. The circle does not intersect or cut though. Okay. That's grade 10. Alright, so I can delete that page. Just spoke about the common tangents now. See, I duplicated that. Now we're looking at example 1, and example 1 is on page 306. I'm moving too slow. Alright. So example 1 is on page 306, and it's for exercise 9.6 on page 300. Okay. We are told that in the accompanying diagram, AB is a diameter to the circle. So if AB is a diameter, what do we know? AB is a diameter, what do we know? Many things, yes? A2 and C2 and 3 adds up to 90 degrees. Okay, that will be 90 here. So there already we have C2. Not so. Then we are told that, okay, then there's other things that we can also consider, but okay, then we are told that PCQ is a tangent. If PCQ is a tangent, what do we know? C4 is equal to angle A. Not so, there's your tangent. So there's your triangle. So C4 is equal to angle A. Can you all see that, people? We can go the other way as well. There's your tangent. What if that was the triangle you are using? Then C4 is also equal to angle D. Also that angle is C1 and 2 is equal to B1 and 2. Not so? Right. Then we are told that ACC, BCD and BD are drawn. Angle C3 is 42, angle C4 is 33. The first question is calculate the A, says calculate angle C2, B, so calculate angle A, C, so calculate angle D, and D, so calculate C1. Okay. All okay with that? Right. So let's go. So how are we going to calculate C2? We said that's going to be 90 degrees, not so? So what do we say? Angle C2 plus 42 is equal to 90 degrees. Why? Angle in semicircle. Okay. So angle C2 works out to be 48 degrees. Is that correct? Huh? Yes, 48 degrees. Okay, now I can't add, no? Right. Let's look at B. B, they ask you to calculate angle A. So what is angle A? How do you calculate angle A? We see that angle C4 is equal to angle A, which is 33 degrees. So angle A is equal to 33 degrees. Why? Tan chord theorem. Okay, normally we write the word theorem as well. Tan chord theorem. I know it's behind probably the calculator at this point. Okay. Remember, this the link to the theorem can also be found in the description box below. Okay. C, they want you to work out angle D. So what is angle D equal to? 33 degrees. Why? Angles in the same segment. Or we could have gone with the tan chord theorem. Not so. So I'm going to say angle D is equal to 33 degrees. Tan chord theorem. Or you could have said angles in the same segment. Okay. Angle C1. Angle C1. Here's angle C1. How do we calculate C1? Angles on a straight line. So C1 is equal to 180 minus 90 minus 33. Or we could have said 180 minus 48 minus 42 minus 90. Okay? And this is angles on a straight line. So that gives you an angle of 57 degrees. Okay? Any confusion, people? No? Can I carry on? Let's look at example 2. Example 2 is on page 307, correct? Right. Example 2 is on page 307. Here we are told that ACD is a tangent to the circle at C. So ACD is this line here. If this is a tangent at this point here, what can we conclude? What can we conclude there? Many things, yes? We can say that A2 is equal to A2 is equal to what? Angle C. E. Why? What do we notice here? The triangle. So angle C2 is equal to angle E. Why? Tan chord theorem is. And C4 is also equal to F2. Why? Tan chord theorem. Can you see it works both ways? Okay. Then we are told that AC is equal to AB. So if these lines are equal, what do we know? That C1 is equal to angle B, but C1 is the same as C4, not so? So there we go, so that will have the same marking and that will have the same marking. Why would angle B be equal to angle C1? Angles opposite equal side. Yes. Then angle A1 is 47, angle A2 is 33. They want you to, what does magnitude mean? The size. Calculate the magnitude of angle C1. So we C1, yes, we can go with some of triangles here, not so? Right, and then the one F2. F2 is the same as C1, yes, and then angle E, which is this angle here, which is the same as that angle B. Okay, so we have a plan going. Alright, so let's start. Where do we start? Okay, you can just tell me what you must calculate first. What did I ask you to calculate first? C1. Okay. So we said that C1 is equal to angle B. Why is angle C1 equal to angle B? Angles opposite equal sides. People in geometry, no? It's not only about getting the answer. It's about laying your work out systematically. Setting up an argument. Okay? You can get the answer right and get 0 out of 6. 0 out of 5. No? It's about logic and the layout of your work. So C1 is equal to angle B. So now I'm going to go with the fact that angles adds up to 180. Reason? Sum of triangle. So instead of saying angle B plus C1 plus 47, I just say 2C1 plus 47 is equal to 180. Why? Sum of triangles. This triangle BAC. Okay. They want you to work with decimals here. Just check if that the 47 they didn't change in the textbook. They got 47. Okay. So angle C1 works out to be 180 degrees. 180. Whoops. Minus 47 divided by 2 gives us 66.5 degrees. Okay, you all okay with that? That put here 66.5. 66.5. Okay, so I got A1 sorted now. Okay. See any confusion? No. What did we ask us to calculate? F2. But we know that F2 is the same as C4. But we know what C4 is. What is C4? 66.5. Why? C4 is 66.5. It's vertically opposite angles. Okay. Then we said that C4 is the same as F2. We say F2 is equal to 66.5. Why? Tan chord theorem. Okay. And there's F2 sorted. Easy, no? I can't help it, maths is so easy. Right. People, as you can see, what does question C ask? Angle E. Angle E. But we see that angle E is the same as angle C2. Okay? Oh, but what do we notice here? What do you see here? Exterior angle is equal to the interior, the sum of the interior opposite angles. Did you see that? So I can say that 66.5 is equal to A2, which is 33 degrees, plus angle E. Why? Because we see it's the exterior angle of triangle. And it's triangle ACE. Okay, so angle E works out to be 33.5. Is that correct? Huh? Yes. Any confusion? Is there the D part to this question? Huh? Why are you guys shy for the new teacher in the class? Huh? You guys understand? Okay. So let's go to the last one quickly. It's example 3, and example 3 is on page 308. Example 3 is on page 308. Right, so we are told that we are told that AQ is a tangent to the circle at Q. Right. People, if you follow this, what I'm doing here all the time, read through this, if you read through the introduction to the sum, the diagram just becomes so much easier to understand or work with, okay? Without looking at what is asked for, we work through the diagram, the information given. We are told that AQ is a tangent to the circle at Q. So if AQ is a tangent at Q, then what do we know? Q1 is equal to angle P. You see that? Then we are told that PQ, chords PQ and PB are drawn with PB produced to meet the tangent at A, which means to say produce is extended. Can you see that? So it's produced, it's extended, and it meets at this point A here. Okay. Then we are told that AR is drawn parallel to QP. If AR is drawn parallel to QP, what can we say? Alternate angle. Can you all see the alternate angles? We can now say that angle P is equal to angle A2. Yes, you can use co-interior angles. But if you look at that thing, we got that unknown, that is unknown, and many other things. Why did I highlight the alternate angles? Because point P is already marked. Can you see that? You see that marking there? And that is what made me want to mark that. So what do we notice without reading further? A2 is actually equal to Q1. Not so? Can you see? Why is it equal? It has the same marking. Can you see that, people? Then we are told that QB is drawn. Prove that RA is a tangent to the circle ABQ in A, or at A. Okay. Now, the question you should be asking yourselves, if AR was a tangent to the circle, if AR was a tangent to the circle, that's not AR, isn't it? Okay, that part wasn't A, AR, this is E and Q. If this was a tangent, then what do we know? A2 would have been equal to angle Q. In this case, angle Q1. Can you see that, people? If it was a tangent to the circle. Now, to prove that it is a tangent to the circle, we now prove that angle O1 is actually equal to A2. But we knew that when we worked with the diagram, we already proved it. You guys understand? So this is how we answer this question. So we go on saying, firstly, so when we start off by letting one of the angles be x. Do we have to introduce our x? No. This makes life easier for us. Okay. where do we start? We start off by saying let angle A2 equals x. So if angle A2 is equal to x, you guys are did you forget what you must prove? You guys got it still. So angle A2, if it is A2 equals x, which other angle is equal to x? Angle P. So angle P is equal to x. Why? Alternate angles with QP being parallel to AR. Okay, so you x lies here. Now what? Q1, yes, is equal to x. Why? Tan chord theorem. Okay. Now what? Now we can see that now that A2 is equal to Q1. Huh? So we state the obvious. What do we say? Since yes, A2 is equal to Q1, which is equal to x. Answer the question. Therefore, AR is a tangent. To circle through Q B A. Why? Because angle between line and chord equals angle in alternate segment. Oh, I'm sure most of you will right now converse of tan chord here. That's it. Something like this is worth 4 marks. And we mark it as follows. Important to understand. How much you say 6? You think it's Christmas. Alright. 1, 2. Making this link 3. And then 4 on your reason. This is a reason mark. Okay, you must get the reason right. No? It's either that or converse of tan chord theorem. You can't write it before you're stating, before you're answering the question. It must be written next to or afterwards. Okay. Well, some people always lose it out. Sometimes it's 3 marks for this stuff. Okay. That's because you're going to write it for the first time in your exam, so it will be 4. Okay. Normally, or at times it's 3 marks. Okay. People, any questions here? Any confusion? Taba? Oh, you Taba. What's her name? Maja. Did I get it right? Right. Then tomorrow we will look at non-numerical examples. People, with this you should be able to do exercise 9 points. Okay, at this point, we'll stop the video. The full lesson to this can be found also in the description box below. Okay. Right, let's go to the